All right, in this lesson here, what we're going to be doing is talking about classes. This is where things start to get classy.
Oh, yeah.
This is where we get into the world of object-oriented programming. What we're going to be talking about in this lesson here is, well, first of all, what classes are, how we can use them. We're going to take a look at the basic syntax for classes. And then we're going to look at a basic point class with variables. So this is a class type that it's our own custom class, if you will. And then from there, and we're going to get into talking about the constructor, the destructor, using class instances, and then we're going to add some functionality to it, and of course, test all that out, make sure it all jamming good, and you guys understand it, and I, as the student, understand what it is. And then we're going to talk about operating overloading, and that's definitely some cool stuff.
Oh, yeah.
So a lot of neat things in this lesson. Again, it's a foundation lesson. A very important one, especially for the basis of object-oriented programming. So with that, I'll go ahead and turn it over to Mr. Joel Van Inwick.
Woohoo! All right, so first, what is a class? A class is sort of, kind of,
a group of students that gather and listen to an instructor.
No.
Oh, I thought I was being smart.
Oh.
My bad. Okay.
You weren't.
What's a class?
Okay, a class is basically like a structure, but it also adds functionality to it. So, what would you like to add to that?
I just like to, it's an encapsulation of an idea again, and
encapsulation.
Encapsulation. We had lots of talks today about. That's my favorite word, encapsulation. Encapsulation of an idea with related variables, data types, and the functionality to manipulate that data.
Right. So, in our example, if
you're a beginner,
yeah.
Can I say it in a different way?
Sure.
It's a blueprint.
Okay.
It's like a blueprint for what's going to become an object. We'll make an instance of the class.
Right.
And it's its own entity that's got its own functionality. And
right.
What's cool is with it being a blueprint, we can then define two objects.
Yeah.
From the same thing that have the same functionality, but yet they're different objects. They have their own individuality going on.
Yeah, they do.
Just like when we had two different players in our structures.
Yeah, exactly.
There were two entities unto themselves of the same.
There you go. Right.
Type of data.
Right.
Exactly.
And you could kind of think of it, just to press it a little bit more, like a person. A person has, as with our structure, we had like weight, height, age, name, but that person can do various things. You can apply various things to that data, et cetera, et cetera. You get the idea. So, I guess the first thing we should do is just kind of show a simple class example with the syntax.
Yeah, because unfortunately we need to know the rules of how to write the class before we can actually use the class.
Yeah. So, again, we're going to use the point class. So you just say class.
And just as a reminder, everybody, the point class we was talking about earlier, a point in space, an X value, a Y value, and a Z value. Just as a reminder so everybody goes, point. Oh, yeah, I remember.
Yeah. So let's say class, point, and then just like our structure, we're going to have opening and closing braces followed by a semicolon. Now, inside of here, we have two different sections. What are those sections?
We have public.
Public.
And we have private.
And we actually have another type as well, don't we?
We do. It's called protected.
Protected. I'll just put it here. We won't use it just yet. This is more useful when we start dealing with inheritance.
Which is going to be the next
Which is the next
section.
Lesson. So we'll try to not talk about that too much. Now, the first thing is the constructor. Now, what is the constructor, Dan?
The constructor is called when you first create an instance of a class.
When you create the instance of the class object.
Of the class object.
Right. So the constructor is defined just like a function, but this function always has the same name as your class. So point, and it has no return type.
No return type.
No return type. And the arguments can be pretty much anything you want, something that you'll use to set the data inside.
Yes.
So in our case, since we have x, y, and z, we'll say float x, float y, and float z. So, something like that.
That looks
that's a simple constructor. Now, inside of this point class, we need to define these three values, this x, y, and z.
This is going to be our data that is contained inside of the class.
That's right. So private is where we would put that because it's our own. It's something that we don't want everyone to be able to see, like our age. Not everyone wants other people to know their age. It's my private age. I'm not going to tell you unless you really, really nicely ask.
Or say your social security number, your credit card number, something that you want to keep secure and as untouchable as possible.
That's right. So you want to put it in private, and we'll call this float. No, not caps. Float x, y, and z. Simple as that. So that's in the private. Now,
I do want to say something, though, quickly.
Try.
The point constructor, just like any function, doesn't have to have x, y, or z as its variables.
In fact, we could go in here and say point and have no arguments.
That's true.
So, we'll just leave that there for now.
I'm also just thinking about the arguments themselves. Float x, float y, float z could become confusing with our points class x, y,
Actually,
z.
you're right. How about the names? If we just change the names, that should make it clearer, wouldn't you say?
I would say so.
So fx, f_y, and f_z. That's a little bit more clear.
Yep.
So, now, these functions, these two constructors that we have are currently not defined. They're not going to do anything. So we need to make sure they do something. To do this, we can come down here after our class is defined.
Well, this is just like a function when we were defining the
prototype.
The prototype.
Yeah. And now we're going to actually create it. So inside of here, you're going to say point, then colon.
That's important.
This is important. This is saying that we're going to take inside the point class, which function are we going to be dealing with?
Yep.
So in this case, we want point. And we're going to pass it the right number of arguments as we are supposed to do. So float f_x. And of course we could copy it, but I like typing, so that's okay. And _z.
And just like a function, because this is a function,
right.
Except we're saying this is a function that belongs to the class point.
Right.
We have to not have a semicolon at the end,
yep.
and we have to
have opening and closing braces.
Yep.
So inside of here is our constructor. What are we going to put in here? Very simple. We can say cout where in the constructor with arguments. Now, the reason I say this is, again, as we said, the constructor is called when the class, instance of the class is created, right?
Yes, it's the very first function that is invoked.
Right, but only one of these constructors is going to be called, not both of them.
Okay.
So, therefore, actually, why don't we just go ahead and show you how to create a point class. You
want instance?
Thank you. An instance of this object, this class. So what I can do, just like we did with the structure, say point, and what do I want to call this point?
My point.
Mylocation. How's that?
Mylocation.
Mylocation.
Mylocation. This is so. I assume you're going to be doing some debugging here.
Yeah.
So we can start following the flow of how.
Right.
Our creation of classes and instancing goes.
Exactly. So if we compile this, you'll notice there's a problem. Unresolved external symbol. Why is that, Dan? I got you.
Yeah. I was looking at the wall for a second, and
okay.
I missed what you typed.
Here's the thing. We did not define, because right here, we did not define any arguments.
So...
This, in the constructor, I could come in here and define, say, an x, a y, and a z, right?
So this is a little different than a function.
This is a little bit different than a function, because this is going to be called only when your object is initially created. It's the constructor. So you're not going to be coming down here and saying, Mylocation point. You're not going to do that.
No. That doesn't make any sense.
No, it doesn't. So since we do not have any arguments, it's going to be calling this function here.
And this is called function overloading.
It's function overloading.
We can have more than one constructor or more than one function that has the same name as long as it has, say, different arguments.
Lists, whatever. Yeah. So inside of here, we need to define the one without arguments. So point, :
which is saying we're going to be defining the function inside of our point class called point.
Yep.
With no arguments.
With no arguments.
All right.
And inside of here, we're going to do the same thing. Print out. We're in the regular constructor. How's that? Yeah, I'll just say, I'll say default constructor.
Yeah, because the technical term for this type of constructor is
the default constructor. Right, because it doesn't have any arguments. So, if we come in here, and let's compile this, it's now happy, because we are able to call the regular point default constructor. If we run this, think we're in the default constructor. It printed out the right one, which means right at this point, it jumped into this function call right here. And if I created another instance of this class, so let's say Dan's location, and I ran this again, it's going to go into the default constructor.
But we have to be careful, because every time we instance a class, we're essentially getting, in a sense, a copy of that class, which is ours to play with and work within.
They're each separate.
They're each separate.
Like, I am different from you.
That's right.
We're two separate entities.
And we're in separate locations. And
we have separate data, everything. You have your own age, I have my own age.
Yep.
Again, for beginners, just knocking out all the fancy terminology, just go back to, that was a blueprint, and you just built 2 objects off that blueprint.
Yep.
You just built my location and Dan's location.
Yep.
2 separate objects built from the blueprint. Again, that's just going back to ultra basics for the beginners out there that are currently going, what the hell are you talking about, Joel?
Exactly.
Or if you like to make cookies,
Yeah.
we have a cookie cutter.
That's right.
And
Yeah.
we are essentially stamping cookies out of some dough.
And it's 2 different cookies.
That's
Yep,
right.
2 entirely different cookies. So, if we come in here, now what if we want this to be defined? What if we want to give it an initial location? You can do so by simply putting the parentheses here and defining a location like 23, 54, and 65.
So instead of calling the default constructor,
Right.
we are calling the constructor that has arguments.
Yes, this one right here. So
it'll,
if we...
it'll work the same. It'll be
work the
called
same.
first, except it's going to be calling that constructor.
Yeah, exactly. So if we run this guy, dinky, the first one actually has the arguments. It's going to say, we're in the constructor with arguments. The second one, Dan's location, does not have any arguments, so it's going to call, we're in the default constructor.
Yeah,
Simple as that.
I don't know where I need to be yet.
Yeah,
Yeah, I'm lost.
Lost.
Ooh. So let's come in here. And another thing, we did talk about default. Didn't we talk about default arguments? No, we did not. All right, so I keep forgetting myself. So what we need to do in here?
Yeah, functions and classes, because classes use functions, are kind of interrelated.
Right.
And if we happen to miss a concept in functions,
It'll just roll
right
over.
into this.
Oh yeah. So right in here, during this definition here, this prototype, if you will,
Mhm.
we can say this has default properties.
Mhm.
So inside of here, we can say something like, well, this one's going to have 1.0.
Okay.
And this one's going to have 1.0 as well.
Okay.
So the default location that we create is going to be at 111, right?
That would make sense.
That would make sense.
So the idea behind this is we don't have to supply parameters.
We don't have to apply parameters.
because we already filled them in ahead of time.
That's right.
Okay.
But here's the thing. That really makes this guy obsolete, doesn't
Yeah,
it?
there's
It
no
does.
reason.
There's
for
no
that.
reason to have that anymore. So what we can do is just delete him out. So go away. Go
so
away.
in a sense, we've made a default constructor without having to create a default constructor.
Yes, kind of, sort of.
We get two for the price of one.
Yeah.
That is nice.
Yeah, it is nice. If we come in here and compile this, think everything's good. Now, there is something you need to be aware of. If you tried copying this right now, let's just do this. Copy, and let's paste this in here. Here's going to be an issue. Think, oh my gosh, redefinition of default parameter. Parameter 1, parameter 2, parameter 3.
I remember this. This was a headache in
Yeah.
my early days of programming.
This can cause you some headache, because up to this point, we've always said you can just directly copy and paste it down here. Well, if you're using default parameters, you can't do that.
No.
You can only say the default parameters once, because what if you start doing something like this? Which one is it going to choose? It's not going to know. So just try to keep
So
that
it's
in mind.
always in the definition,
Yeah.
not in the actual implementation.
It's better to do it that way, yeah.
Yeah.
So, with that said, that's good. Now, how do we make this constructor actually do something constructive? Something useful? Very funny, yeah.
Very nice
Programmer
joke.
jokes, yeah. Anyway, what we need to do is, what's the word I'm looking for? Initialize these 3 variables that we have.
because right now
They're undefined.
They're undefined. They could be any value out there.
Yep.
When we make the class, we get memory for X, Y, and Z. It's
Yeah.
automatic memory.
Right.
We don't have to worry about it because it's not a pointer. And
Right.
we haven't made any new calls or anything like
Yeah. So what we need to do is inside of here, say x
Mhm.
equals f underscore x, which is the argument that was passed to us. Y equals f underscore y, and z equals f underscore z.
So if this was called and we had no parameters given to us, like we have in the second example,
Right. This is going to be 1, 1, and 1.
and 1 because of the default values.
Because of the default values that we have.
But if we pass values to
it
the
will
constructor,
replace these with whatever we pass.
so it would be 23, 54, and
Right.
65.
And another thing that is good to point out, I could, if I wanted to, actually, let me first show this actually working so that you can see it. Let's see, what do I want to do? I'm just going to walk through it so you can see it.
That sounds excellent.
So go into here. So x, let's go back to locals here. X is going to be set, if we expand this out, this is ourselves, the current class that the instance of the class that we're currently in.
It's sort of like everyone knows how to reference themselves. In this case, I would say, I am Dan.
Right.
I is how
My
I
age
reference.
is blah, 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 blah,
Yeah.
blah. Right.
And the way that the computer does it is by saying
This. Exactly. So we can say x equals fx, dink, so 23, 54, and 65. For Dan's location, dink f_x, y, and z are all 1. So if we look at these, if we expand this, you'll notice that these are currently undefined because we're a new object. We're
because
not working
it's a
with
different
the same
this. We're now talking about
Dan's
you
location
over there, which is a different this.
Exactly.
That makes sense.
Yeah, it does, actually. So if we have y equals, everything's going to be 1, 1, 1. Dink. Great. Now, let me stop debugging for a second. What if I was to remove the last parameter? What's that going to do?
Well, Buzz, as a student, what would you venture a guess at?
Oh, let's see. As a student, I'd probably say we're just going to get a big fat error because our argument list is not right.
Okay. So...
it worked.
And then the student would be surprised.
Yes, he would, because what's going on here is it knows...
It's defaulting if it doesn't receive that argument.
That's right. So the last argument, which is f_z, is still going to be 1. So let's go into here, just to prove my point. Go in here, dink. You'll notice f_z is now 1.0.
But there's something to keep in mind that the way that default parameters work and feeding parameters, it's 1-to-1, which means you can't go out of order and jump around. Like, I can't assign fy as a value and not define fx and fz.
If I was to get rid of this right here, it wouldn't be a good thing.
We'd have problems right now.
We'd have problems.
Well, actually,
look at that.
Oh, yeah.
Missing default parameter for parameter 2. Because, you won't be able to define it accurately.
Right.
So, all right, enough discussion on default parameters.
But let me just add one thing in. What Dan said is dead on. Something that we didn't really push in the last lesson, and that is the one-for-one thing. And that is another area that I've seen students
just panic on
so many times because they get confused. As in, here's my argument list. Here's the arguments I'm passing into it. How do I know which one goes first? And it's because it seems to us, it just seems like duh.
Duh.
But that a lot of people get confused with this. If you've got where you're taking in int x, int y, and int z, the numbers that you're feeding in, those three numbers, the very first number goes into int x, the second number into the second one, the third, and so on.
If you need to, you can think about it drawing a line. You're going to draw a line from 23 to x, and then
straight up. And
54 to y, and it's visual that way.
Right.
They go in order, period.
Awesome. So, with that out of the way, that all fixed up, let me just put a number back in here because I want a number in there. And one other thing that's very common in a class is a destructor. A destructor is the exact opposite of a constructor. It is run at when your class is destroyed.
Death.
Yeah, when it's dying,
And that's going to be dependent upon scope.
Yes.
It depends on if you
where
define,
it's going to really die.
Yeah, if you define this class, the instance of the class inside of a function,
like we
at
do
the end of that function, it's going to call the destructor.
Yep. So at this point, destructors are just as simple, but the tilde sign, or however you want to pronounce it, and just the name of the class. Point.
Which is the button just left of the one
exactly.
on the U.S. International Standard keyboard.
Awesome.
And
there's not going to be any arguments. You never need to pass any arguments to this guy.
No, that's just the way it is.
Yep.
It's a rule. You put a tilde in front of the name, and you put 2 parentheses at the end.
Right. In our case, the destructor is only going to be really, really necessary if you are allocating dynamic memory within your class. So if you define like 80 bytes for a name or something like that, we're going to need to destroy that memory at some point. But when do we know to destroy it? Well, when the class is destroyed. So we can just delete it at that time. We're just going to define it here, but we're not going to have it do anything.
Yeah, that's going to be something that we'll talk more about in the next lessons.
Right, when it becomes actually really useful.
Yeah, when we're actually developing a program.
Right. Dink, dink. So, right like that, it's just going to be empty. Let's just compile this guy.
Actually, before you do that, why don't you
that idea.
Yeah, go ahead and put in the cout with you're in the destructor, and we are about to go to Oblivion. Or something shorter.
That was great.
Does that make you happy?
Oh, that makes me very happy.
All right. So if we run this, you'll notice which is going to be destructed first. This is kind of important as well. All right. All right. We're in the constructor with arguments. Then the 2 are destroyed.
Yes, and this could be interesting because Joel, I think, was trying to figure out how we could show who gets destroyed first.
Actually, I think we can just print out this. That would kind of do it, wouldn't it?
That would give us a number.
Yeah, it would give us a number. That will be okay. So inside of here, constructor with arguments, let's just get rid of this right here and put in...
No, let's get rid of this and put in this. That's awesome.
So it's going to print out a number.
Yeah, which is our unique identifier for the class.
Right, it's an address.
It's an address.
And that means we're in the constructor. Now when we're in the destructor, we'll print out this as well. So this is just like a unique identifier of some sort. So let's compile this guy. Let's run it. Look at this. We're in the constructor, 124864. And then it constructs the other one.
So
then
we have two different memory addresses where these creatures are living.
That's right. Then it kills the one that was created first.
Okay.
And then it kills the one we created last.
Now that's just depending upon how it was made inside of the function.
That's right.
Its technical term is called Fifo, which is first in, first out.
Yeah.
And you can think of it kind of as a stack of dinner plates. If you ever go to a cafeteria, you have a stack of plates. Well, if you put a plate on, what's the first one that's going to come off when you take off that top plate?
Right.
Well, it's the one that you just put on.
Yeah.
Yeah, you're right.
Yeah,
you're right. Dan's like struggling.
I have this. I'm thinking there's also another
Thinking
technical
about
term.
pulling the plate out from the bottom?
Yeah, and that would just break everything.
Yeah.
Bad.
that would break
Let's not go there. All right, so everything's working good there. Now let's start defining some of the functions inside of this point class.
And we're going to do that in public. The reason for we're doing it inside of public is it's going to work kind of like a class, or not a class, we're working with a structure, where we can use dot notation to reference this functionality.
Actually, that brings up a good point. Right now, inside of main, we can't access X, Y, and Z. So what if we wanted to do that? I mean, if we come down into our main here, and since we have Mylocation, can I just go Mylocation, and we can use the dot notation?
Oh, wait, but we didn't get a pop-up.
Right.
Which means right now we have no functions that are accessible to us, but we also have no data elements.
Which means
that
it's kind of, it's almost like it's private.
It's private.
I wonder why.
I don't know.
So if we say like Mylocation.x equals 54,
error CC225.
It's not going to be happy. Well, that's a warning. My bad. This one right here cannot access private member declared in class. It doesn't like that at all.
So we need to make functions that can access
the
this
data.
Right.
Because as a class, like we did in the constructor, we can access our private data.
Yeah, we can access our own stuff. And the important thing is when you're working in an object-oriented environment, you want to make sure that you have functions to manipulate the data so that you don't have direct access to the data.
Exactly.
Because that can get messy. I mean, if everybody could like change your social security number, I mean,
that
would be a problem. Yeah. You would have to go through the right channels before you can change certain things.
And it's just a security protection.
It's a security thing. So inside of here we can define, say, float, if I could type, get x. And it's not going to have any parameters. So it's going to return x, which we have inside of there. And it's a public variable. I mean, function.
It's a public function accessing private data.
Yeah.
So if we come into here, we can say it's a member of point, and it's going to be get x. But what are we returning? Look up here. We have float.
Okay, so we want to return a float.
So right here we put float, just like we did before.
So you can think of it, I mean, again, this is to get back to the notation of referencing how to define a class name inside of, a function name inside of a class.
Yeah.
It's the same, except you're saying point,
right, who is it a part of?
X, get X.
Yeah.
Instead of just saying get X, because we have to make sure we reference who it belongs to.
Exactly. So, of course, no parameters. And here's how hard this function is going to be. Brace yourselves. Return.
Wait.
Ready?
Okay, yeah.
X.
Wow.
I know, it's tough.
Yeah, that's it, I'm done.
Okay. Yeah,
my brain is now spent. Yeah.
Now we can say cout, Mylocation.
Now you need the function in there.
Dot get x.
Which will look exactly like a structure.
Yep. But we're calling a function now.
But we're calling a function.
Yep. And then we can just say and L. Now, if we build this, except for the warnings, everything's cool. And look at that. 23. Which, if you look at Mylocation, is
that's
the
the
first
value
one.
that you put on it.
Isn't that awesome?
Very cool.
Now, to define the other ones, let's do something bad. Well, good-ish.
So we're going to make more accessor functions.
Exactly. So we can say get x, get y, and get z. Copy. And just change these around. I know that was hard.
And don't forget, we have to define them inside of our class.
Yes, we do. If we do not define them here, and we build right at this point, we get all sorts of things. Get y is not a member of point, blah, blah, blah. So we need to make sure that we define it in here. So get y and get z. Isn't that cool?
I like that.
Yeah, I like it too. So inside of here, that's all set up. If we build this, everything's good. Now, how do we change x, y, and z? Because of the private, we can't even change them, right?
Right.
So what we need to do is come up to here and add set x, set y, and set z.
Yeah, that's so that we can
Instead of just
indirectly
getting
set
the
the
information, yeah, we can indirectly set it.
So we can come in here, copy these again. I know, I'm lazy, but come in here, set x, set y, and set z. But do we really need to return anything?
Well, no, because what we want to do is
set a value.
Set a value.
Right.
So it makes sense not to return a value, which is void.
Right. At sometimes when you're setting certain values, if it's a more complicated type class, you may want to return whether it was successful or not.
Exactly.
But in our case,
No.
you can't go wrong. You know.
Yeah, because it's just so
easy.
simple.
Yeah. So the argument is going to be float x because we're passing what we want to change it to.
That's right. And we're using capital letters here.
Not just to distinguish it
between the lowercase x, y, and z.
Which is our private data. So float x, y, and z. Now, we can come in here, and let's define the first one. Void.
Which is our return type.
Yep.
And then we need the name, which is a long name.
Point set x. And it's going to pass it a float, which is x. Inside of here, I know this is going to be hard. X equals capital X. We're done.
Ooh,
I know.
wow.
Yeah. It's tough. And then we can copy this guy and just paste it for the rest of them. So, y.
Actually, technically, Joel.
Technically what?
Technically, you don't even have to change the capital X.
No, I don't.
This is just to get back to the whole function thing.
Yeah.
Where the names of the parameters, argument list, doesn't have to
change, or doesn't have to match up.
You just have to match up one-to-one as you call them.
Yep. And it's just, as a practice, it is better to do that, but it is true. You don't have to have
You don't
it
have
same.
to.
So, let's compile that guy. Ooh, it looks like it worked. Now, let's go into here and test it out. Mylocation dot, and it's not coming up. Don't worry about that. It's just not coming up right now for some reason. So set x, and we want one argument, and we'll say, let's change this to 12. So x is going to be set to 12.
Okay.
End that off, and when we say get x, it should now be set to 12, so it should print out 12.
Before we do this, though, can we just get rid of the Dan's location? I want to get lost for a while, just so I don't clutter up the world.
Okay. Yeah, you clutter up the world in real life, too.
I take up space.
Yeah.
Okay, say.
So let's print that out. Check it out. We're in the constructor, then we changed it to 12 and printed it. So everything's cool.
Because it started at 23.
It started at 23.
We use the set function, which would access our private data.
Yep.
And we set it to 12, our x variable to 12. And then we use the accessor function, getX, to print that data.
Exactly. How cool is that?
That's really nice.
Yeah, it is. But here's another thing that kind of, what if you wanted to change x, y, and z from my location to 1, 2, 3? You'd have to do the following.
Now, wait,
Ding,
say
ding.
that. Oh, yeah. Oh, I see what you're saying. Okay.
Look
you
at
said
that.
that a little fast.
Oh, I did?
Yeah, I just was catching it.
I can say it 2 times faster.
Oh, jeez.
All right, so what if we wanted to change my location's XYZ value to 1, 2, and 3?
Okay.
You would have to do this. Have 3 separate lines that does that.
Which isn't a big deal.
No, it's not a big deal.
But, we could do it more efficiently.
Oh, yeah, much more efficiently.
Oh, yeah.
So we can come into here.
Which is here meaning our definition for the class.
Yeah, our definition. All right, so if you're in here and you say, we don't want to return anything.
No.
We just want to set X, Y, and Z all at the same time. How cool is that? Now we're going to have, how many arguments, Buzz?
Oh, gee, let's see. You've got an X that you have to worry about, a Y that you have to worry about, and a Z. So that, as a student, of course.
Yeah.
1, 2, 3. Yeah, 3.
Awesome. You're the most awesome student.
You said earlier that you separate these in the argument list with commas.
Dude, you rock, man.
Thank you,
wow.
Thank you.
I'll give you a cookie afterwards. Thanks for reading your script, by the way.
Oh, yeah, no problem.
All right, float X, Y, and Z. Now, this is going to be a tough one to implement, isn't it, Dan?
Well, we have actually 2 ways to implement this.
Uh-oh.
And this comes back into a stylistic concern, which Joel and I may differ on.
I know what you're thinking, too.
Yeah, so go ahead and talk about it.
And the battle's on.
What am I doing wrong, first of all? What am I missing?
Oh, well, remember that when we use classes,
right,
and we're going to be defining the functions, we have to use what I'd like to call the long name.
Right.
Which is...
You're missing point.
We have to use point.
Right. point and our almighty colon, also
colon.
called the scope operator.
That's right.
Ding, ding. So there it is. Set X, Y, and Z. Make sure that builds. Everything's cool. Now we needed to do something.
Yeah, that would be the point of a function.
Very
To have
funny, Dan.
functionality.
Yeah. So we can come in here and say X equals X,
Yep.
Y equals Y,
Yep.
and Z equals Z.
Yep.
So what were you thinking, Dan?
You see, I'm of the school that says if you already have functionality that can set a variable inside of your class, use that function.
And this is totally true in this case because, say for instance we had a more complex. In our case, this is extremely simple, so
Yes.
the likelihood of anything changing significantly is not very likely.
But what if for some reason we wanted to redeclare XYZ to be
Double.
ABC?
Or ABC. Yeah.
Just change the variable names. If we use functions instead of actually referencing the variables inside the class, we only have to change 6 functions.
That's right. Whereas we would have to change this
Every single. Well, what if we
function.
had 10 more functions that referenced XYZ?
Yep. So instead, what we could do, let's just comment this block out. This code would work, mind you.
That's completely legitimate, especially when you're dealing with something very
so
simple.
Right. But just to be accurate, we're going to do this. And when you call your own functions, your own functions, you can simply say set X.
Yeah, because
you don't need.
You already know yourself.
Yeah, you know who you are.
You know who you are, and you can reference your own functionality.
That's right. So you can come in here and just say set X equal to the new capital X.
I like that.
And we can say set Y. Now, the reason in this case you wouldn't necessarily use this technique is just because it's slower. Calling a function and then having that function set it is slower than just directly setting it.
And Joel's mindset is towards games.
Yeah.
And games, you want everything to be
Ultra fast.
as fast as possible.
That's right.
And my mindset is more along the
Readability.
lines of readability.
Yeah.
Exactly.
So with that said, that's cool. We could also, if we wanted to, create a get X, Y, and Z function. Now this kind of, we're not actually going to return something that has all three at once.
Wait.
Yeah.
If we ask Buzz, how can we get a
Yeah,
value?
how can we get the value?
Without actually returning values? How can we get the functionality inside of a function? With a function.
Huh.
Okay.
Yeah.
Yeah.
We talked about, remember the reference?
Yes, remember the reference. The reference is good. It's our friend. So in this case, since we want to get X, Y, and Z, we can't return X, Y, and Z in one variable.
No.
No, we can't do that.
No, because we can only return one value.
That's right. So in our parameters, we will pass X, Y, and Z, and they'll all be referenced. And then we can pass variables that will be changed by that function. So we're not going to return anything, so it's going to be void. And we're going to say get X, Y, and Z.
You know what I feel happening after we get this function made?
What?
I feel some debugging coming on.
Oh.
Just to get the point home.
Yeah, okay. So float, ampersand, X. So that's a
Capital
reference.
X.
Capital X. Yeah, my bad. Float, ampersand, capital Y. And float, ampersand, capital Z. Dink. Now we're going to copy this, because I'm lazy.
And you'll also notice something that Joel's doing. He's grouping.
I am grouping.
Which is actually kind of nice. It keeps your code
clean
and in units. I like the word unit, too. It keeps it in units, encapsulation, and it's easier to edit.
It is, definitely.
If you keep everything together, you just know where to find it.
Oh, definitely. So inside of here, of course, we need to say point plus our colon. Get rid of the semicolon. Inside of here, what we're going to do is say X equals, and we can use get X or directly set it.
Yep.
Get X, and then just get X without any parameters.
X, yeah,
right.
Because it takes no arguments.
Right. So Y equals get Y, and Z equals get Z. Makes sense, right? So we can come into here, and let's, way down here, my bad. Come into here, let's define an X, Y, and Z.
Here being the main function.
Main function.
This is where the program's actually going to be
That's why you're
running.
here, Dan, so you can specify what my here's are.
Yeah, it's a bad habit of mine. I tend to be a little bit picky when it comes to
That's okay. That's cool.
Conversation.
So let's define an X, Y, and Z.
Okay.
Now, let's go into Mylocation. So Mylocation dot get X, Y, Z.
Okay.
And we're going to pass it 3 arguments, X, Y, and Z. Now, do we need the ampersand in front of X, Y, and Z?
Well, passing by reference is the same as saying I'm going to use simplified pointers.
Right.
So, no, I do not need the memory address. I need to pass the variable name.
Awesome. So in this case, it's going to do exactly what we want. Let's get rid of this. And let's print out X, Y, and Z with spaces. X, and space, Y, space, and Z.
Okay.
Now, what should this give us?
Well, if we're looking at this the way it is,
Yep.
X should get the value 23.
Right.
Y should get the value 54.
Yep.
And Z should get 32.
Awesome. So let's run this and make sure everything... Ooh, look.
Error.
I made a boo-boo. All right. From int, parameter 1 from int to float. I declared this as a int. I meant that to be a float. Yeah.
Because the float contains decimal information.
Right.
So 1.23469.
Yeah. And since this is a point in the world, that's a complex point in the world, so you need it to be floats.
That's true.
Yeah. So let's compile this guy. Everyone's happy. Let's press Control F5. Check it out. 23, 54, and 32. But now, debugging. So let's come in here, and with our breakpoint set on our point Mylocation, let's press F5.
So we're going to see it go into the constructor.
Yep. First, if we press F11, dink, we're in the constructor.
This is the template constructor.
This
so
is the template.
This is our constructor that we're currently our own. This.
And if we expand this just here, you'll notice it's currently undefined. Skip, dink, dink, everything's now set.
That looks very nice.
Now, to the next one, mylocation.getXYZ. Dink, now we're in here. X, Y, and Z, which we pass to this function, is currently undefined because, let me just scroll back down to main for a second. Excuse me. We didn't define anything. They're not being initialized.
And that is the area of memory that it's going to be working with.
Yep. So if we come up to here and say x equals getXY, we're going to jump into another function, aren't we?
We are.
So if I press F11, dink, I went down into getX, which all it's going to do is return x, which if we expand this again, it's going to be 23. So dink, and we go back.
And then with the assignment...
With the assignment, we say x, capital X, equals getX, what we just got from the function.
Which will be 23.
Which will be 23, and you'll notice down here, it changed.
Will in turn change the variable...
Which has changed x.
Yeah, it has changed x.
Yep. So now if we say y, it'll set y, and z, it'll set z. Perfect. Now if we print this out, and we look at here, everything's nice and pretty. So let's stop debugging. Now, that's a very, very simple class, right?
Yeah, because right now we have the concept of what the point is.
Yep.
We represent it inside of the class with our variables.
Mm-hmm.
We have the ability to set that information, and we have the ability to get that information.
Yep.
So it sounds like a point to me.
Yeah, it sounds like a point to me, too.
But can we make it better?
Yes, we can. We can add operators to this guy as well.
Now, explain to me just quick an operator again.
An operator. An operator is like an addition. You can say 3 plus 5.
Okay.
3 plus 5 is 8. Well, what if you said point plus point? So XYZ plus XYZ. Well, it's not going to directly know how to add those two together.
No, because, well, point doesn't actually exist as a default variable type. It's
No,
our variable type, so we're kind of responsible for everything that it knows.
That's right. And what if we tried to print this out? What if we tried to print out a point? So instead of saying X, Y, and Z and having get X, Y, Z, let's delete this for a second. Oh, actually for a long second.
It's going to oblivion.
Yeah, it is. Let's see out Mylocation. So we're trying to output Mylocation, right? Which is 3 data values.
Yeah, we want it to print 23, 54.
Right, followed by
32.
spaces or something.
Oh, but no.
No operator found which takes a right-hand operand of type point. What does that mean? That means we can't do it? That's not right. Well,
can we write a function to let us do it?
Yes, we can.
All right.
This is through operator overloading. Just like we were talking about before, we can overload certain functions so that we can make it do what we want it to do.
Mm-hmm.
So,
and in this case, we're going to overload an operator because an operator technically is a function.
That's right. Technically, it is a function. I won't try to get too deep into that.
No, just accept it.
Just accept it. So right now, cout with this is the operator that we need to overload. With cout is an O stream in this case. Console out.
And an O stream is a class that is defined inside of C++.
Yep.
Which lets us deal with output of characters and numbers.
Numbers and all that stuff.
All that stuff. Which we've been using throughout
Yes,
everything.
we have. And the way we can define this is OStream. This is going to be the return type for our overloaded operator.
Okay.
And it's going to be ampersand, which means we're going to return a reference to an OStream. Right?
Okay.
Does that make sense?
Well, it makes sense because when we see out, we can see out a number 1 and then the string hello.
Right.
And in order to do that, we could think of it as it's returning a value
right.
at each time, each point. So to string them together, we need to have a string of streams.
Yeah. That does make sense, but I think it'll make perfect sense after we're done with it.
Oh, yeah. It always makes more sense when you see the picture.
Yeah.
Yeah.
So let's say OStream and the ampersand and operator. So we know it's an operator. And what kind of operator are we overloading? Dink, dink, the output operator, if you will.
Okay.
And it's going to have 2 arguments. An OStream, which is going to be the stream that we're outputting to. And we want it to accept a point, which is also going to be a reference, so that we can use it any way we want.
Okay.
And inside of here, this will make sense. Believe me, trust me. Hang in there.
What you'll notice is this is not part of the class.
This is not part of the class. You'll notice we're not
function,
using point, ding, dink anymore.
And this is a function that will operate on this type of class.
That's right.
Okay.
So inside of here, we can say stream, because stream is like cout at this point.
Okay.
So we can say stream with our regular output, p. Actually, you know what? I'm going to change this to a lowercase p to make it easy for me.
Okay.
P dot get x, right?
Mm-hmm.
Followed by space. P dot get y. Followed by space. P dot get z. Followed by an end line.
I would prefer you did not put an end line in there.
Yes, sir.
Well, if you think about it,
Yeah,
if
that
this
is true.
a cout statement, if we can think of stream as being cout,
Yep.
which essentially we can,
Yep.
if we incorporated an end line in this function, every time we called it, we would get a new line at the end of it.
Right.
What if for some reason
We didn't want
that?
Yeah.
It's kind of hard to change your function if you're using it.
Yeah, exactly. So right here, what we're going to do is just return stream. Now, I'm going to explain this, so hang in there. At this point, when I compile this, it's going to be happy. Look at that.
Oh.
It's going to be happy, and it's going to actually work and print out 23, 54, and 32. Whew. Now, how does this work?
I'm waiting to hear this one.
All right. Let's delete that for just a second here.
Okay.
Now, you can think of this as saying, all right, here we go. Cout
Okay.
dot operator followed by that.
Okay.
Think of it that way.
Okay.
It's like calling a function called operator this, and it's passing it 2 operators.
Okay.
Two arguments, my bad. Cout and my location. Does that make sense?
Okay.
So at this point, you can say, okay, cout is just simply calling an operator, calling a function, just like we've been doing this whole time.
So to drive this a little bit further, line 102, we could actually put parentheses around Mylocation and kind of have it match up with the idea of the less than is a function.
Put
Yeah, right there, and at the end of the line.
Right there?
So I'm just saying we can kind of match it up
Yeah, you
that way.
kind of think of it that way. So then we have cout and Mylocation.
Okay.
So when cout gets to here, we're passing a reference to OStream, okay? And we're passing a reference to Mylocation. So stream is essentially cout. It's the exact same thing.
Because you can think of cout was an instance of
A class.
OStream, which is a class.
Yep.
Okay.
And then we're going to output p.getx, p.get y, p.get z. You know that. When we return stream. Now, at this point, since this is our function,
Mm-hmm.
you could think of this as saying, I have OStream. I could, if I wanted to, my OStream. I don't know if this is going to confuse people more, but I could say my OStream equals cout.operate because it's returning an OStream. Does that make sense?
It's just like what we did before. If you have a function that returns a value,
Yep.
you can either have it assigned to something
Or not
have it assigned to something.
Right. And if you have it not assigned to something, what essentially you'll be able to do is stream them together so that at this point you can attach another one, say endl,
Okay.
which is going to call another one.
Which would, in a sense, just be causing a function called endl, you could think, which would
Yep.
make a carriage return to print a new line,
Yep.
and it would return an OStream back into this
Yep.
functionality.
Exactly.
Okay.
So at this point, I'm going to try to leave it there. And you'll notice the way I did this here, it actually let me compile this.
Yes, it did.
Because I have operator that is a function. It is a function. You don't look at this and go, oh my gosh, what is that? That is a function. Don't think it's something freaky deek. It isn't. It's just a simple function. All right. With that out of the way, We now have an implementation of output stream for Mylocation. What if we wanted to do an input stream?
Ooh.
Not that scary. We can actually copy this guy, and instead of OStream, which is output stream, it would be an iStream. Ooh, nice. So we can come in here, and this one is obviously going to be this now, just as when we use cin, console in. This is going to be iStream, and point P is still going to be point P because we need to get information from the user.
Okay, so cin then would be an instance of the iStream class.
Yep.
Okay.
And inside of here we can say, let's just define X, Y, and Z. And now we can use our, get X, Y, Z, and get it from it. Oh, I'm sorry. Stream it into X, Y, and Z.
Yes.
From the user, and then set it X, Y, and Z.
Yes, because set is a function that we have.
Yep.
And that will change our private data of the equivalent X, Y,
and Z. Yep. So we can say stream input X, Y, Z.
Which is just like cin.
Right.
So
exactly like
there's
cin.
nothing too new going on here,
nope.
except stream is cin, essentially.
And now we can just say simply p.set x, y, z. Inside of here, we'll pass it x, y, and z.
Okay. And then we don't need the output because that was just copied. Yeah.
And we do return stream at the end as well, so we can tie them together as we did here.
Okay.
So now at this point, don't want to do that. We can come in here and say the following: cin Mylocation. So now, if we run this, it's going to pause and give us a moment to enter in values. So if we enter 1, 2, 3, press enter, it's going to print out 1, 2, 3 because it just set it from the user input.
Because we overloaded a functionality of an operator.
That's right.
Which is the input operator.
Yep, and we can even come in here and debug it just so you guys can see it more clearly. If I press F11 right now to step into this function, dink, I've just stepped into the function that we've created. So if I come into here, stream, it's going to wait for me to enter it. I can enter something like 54, 23, 65.
I was going to say, you can actually enter that line by line
You can enter it line by line as well. And just some sort of space or break or some sort of white space in between. So now it's going to set X, Y, and Z. We'll just skip over this function. Now it's going to return the stream.
So what's really neat about this is that we've just expanded our class a whole lot.
And we've made it easier for everyone to use, which is very, very cool. So now let's kind of think of something maybe easier for us to do.
Okay. I'm all with the easy.
You're all with the easy.
Yeah, easy.
That's cool.
Easy right now. I'm sure a couple people are saying, "Oh yes, please."
Oh, please, please, please. What if we wanted to assign a point to another point? Let's say we have point Dan's location. I'm sorry, I'm going to have to tie you back into this.
Oh, okay. I've been found.
What if you guys mind if I delete this?
Go ahead.
All right. So I'm going to say my location equals Dan's location.
So this would be kind of like saying if we had two integer variables where a equals 0 and b equals 1, we could say a equals b.
Yep.
Which would set a to be 1.
Now, you'll notice something interesting here. In effect, what should print out? 1, 2, 3. That's what we want, right?
Yes, that's what we want.
And you'll notice something. Think it works.
Ooh.
Here's the thing. At this point, since we do not have any special assignment, we don't have any pointers going on here. It's going to do a direct byte-by-byte shallow copy of all our data from one into the other.
Whoa, you're blowing my mind right now.
Oh, did I just lose a few people?
Yeah.
Okay. What I'm trying to say here is that there's this data for each instance of our class.
Yes.
And it's going to take that data and say we have an X, a Y, and a Z. I'm just going to think of those as bytes in memory, locations in memory.
Okay.
All I'm going to do is take this instance of the class, take his data, and copy it over to the other instance.
So it's automatic in the sense where it will happen, but we don't have any control over it.
We don't have any control over it.
What would really be nice, because what if we had something really complicated?
Right. If
like
we had
we had pointer data.
If we had pointer data, we'd be just...
Because we made the memory.
Yep.
We know where it is, but the system doesn't know where it is.
Right. He would just print out the address.
So it's safer to actually overload another operator and make an equals.
So inside of here, let's first define the prototype of it. So inside of here, we're going to say, what is it going to return? It's going to return a point, because equals operators do that. And it's going to be operator equals.
Okay.
and it's going to accept one argument, a point P.
Okay.
But it's going to be a reference.
Now, this is different than the other function that we made, the other overloaded operators, because
Right.
this one is actually inside of the class.
That's right. This is now part of us.
Okay.
So, inside of here, let's just copy this guy. And let's move all the way down to the top right here.
And that's just a
kind of
grouping.
keeping.
That's
Yeah, it's a grouping
issue
thing.
again.
And, of course, we're going to need point, colon here.
Because we need a long name because it's part of the class.
Yep.
So we need to know who it belongs to.
So this is going to be very, very simple. All we need to do is say set x, because we're in ourselves. We want to change us.
And we always know who we are.
Yep, we know who we are.
Okay.
Then we're going to say take p, which I capitalized again, p dot get x, because we want to call his get x function.
Because he's a class.
Yep.
Or she.
Or whoever.
Or whoever.
Yeah. Set y, p dot get y, and set z, p dot get z. Simple enough, right? Now we just need to return, notice, point. We're returning the value, so we need to make a copy of ourselves and send it back, right?
Yes, we do.
Remember, this. Who is this? This is ourselves. It's an address, right?
Because we know who we are, and we identify ourselves
As
by
this.
this.
But if I said return this, am I returning a value or an address? I'm returning an address.
That's true.
So I don't want to do that. I want to reference this with a star and pass back the value.
Because that's the variable.
That's the variable.
It's
That's
not the memory
us.
location, it's the data that we are.
Yep, exactly. So with that set up, we can now do this. So if we compile this guy right here, all's good, right? Come to here. Now if I press F11, dink, it goes to our operator.
Nice.
So now we have full control over how we want to do it. In fact, we can do something crazy, like set X, Y, and Z. We can get it from his Z, Y, and X.
Oh, that'd be crazy.
It would be crazy,
It would be crazy.
but we could do that at this point since we've defined our own.
Because we controlled the definition and the operation of the equals operator.
We control everything. And when you start getting into your own complex classes, as we will very soon, then you'll find that a lot of these operators, you can't rely on the default operators that are constructed. You need to create your own. So, with that said, we've actually pretty much covered everything about classes.
Everything that we set out to cover.
Everything we set out to cover.
That's a fact.
Yeah. So I guess you want to add anything?
Just a recap on the idea that a class is an encapsulation of an idea that has functionality and attributes to it, like variables. And we can create this class, and we can almost make our own variable type that has functions associated with it. And it just becomes really powerful. It's sort of a step up, a steroid class, so to speak. But it becomes so much more powerful and so much more important as you progress in object-oriented programming.
Very cool. All right. Well, with that, then, we've covered it all. That wraps up this lesson. Thanks a lot.